All right, perfect problem 3 for Math 251. In the first question here, we're told that the Pythagorean identity is sine squared of x plus cosine squared of x equals 1 for any angle x. We're asked to confirm this identity by showing that the derivative of this thing is the same as the derivative of this thing. But the derivative of 1 is just 0. So really what we want to show is the derivative of sine squared plus cosine squared is equal to 0. So we need to find the derivative of sine squared of x plus cosine squared of x. There's a few different ways to do this, but since we don't know the chain rule at this point, we're kind of forced to use our product rule. So in order to use the product rule, we have to rewrite these as products. We have to think about this as the derivative of sine of x times sine of x instead of sine squared of x plus cosine of x times cosine of x. So now we're being asked to find the derivative of the sum of things. We know that's just the sum of the two derivatives. But now we've managed to rewrite this problem in a way that's conducive to using the product rule. Right? This is saying take the derivative of this product of two things. Okay, I can do that. It's the derivative of the first one, sine of x, times the second one, which happens to also be sine of x. And then to that we want to add the derivative of the second one, which happens to be this sine of x. And we want to multiply that by the first one, again, sine of x. And kind of the same idea over here with cosines. If you use the product rule, you get the derivative of cosine times cosine of x plus the derivative of this cosine, and I ran out of room, times cosine of x. And we can evaluate all these derivatives. The derivative of sine is just cosine. So we want cosine of x times sine of x. And then to that we want to add the derivative of sine, again, is just cosine of x. And then over here we got the derivative of cosine, which is negative sine of x. And we got to multiply that by cosine of x for this one. And then add this term again. Again, we get negative sine of x times cosine of x. So really what we have here is cosine of x times sine of x plus cosine of x times sine of x minus cosine of x times sine of x minus cosine of x times sine of x. We get 0. That's what we were hoping to get. That's the right answer because the derivative of, gotta scroll up a little I guess, 1 is just 0. And this is just equal to 1, so the derivative of this better be equal to 0. It is. Alright, second one says use the quotient rule and the fact that the cotangent of x is equal to the cosine of x over the sine of x to basically define the derivative of cotangent. Alright, the derivative of cotangent of x is the same as the derivative of cosine of x over sine of x. And that's because cotangent is the same as cosine over sine. But we can find the derivative of cosine over sine if we use the quotient rule. Quotient rule says take the derivative of the top, cosine of x, multiply that by the bottom, sine of x. From that, subtract the derivative of the bottom, the derivative of sine of x, times the top, cosine of x. And then don't forget to divide that entire thing by the bottom, sine of x, squared. So the derivative of cotangent is this mess, and I can figure out this mess because I know the derivative of cosine is negative sine. So I got negative sine of x times sine of x minus derivative of sine of x is cosine of x. And if you're kind of clever, you can see the Pythagorean identity up here in the top. Maybe I'll make it a little bit more apparent by factoring out a negative 1. If you factor out a negative 1, you got sine squared of x plus cosine squared of x on the top. Right, you pull out a negative from this term and you're left with sine squared plus cosine squared. It's all over sine squared of x. And using the Pythagorean identity, sine squared of x plus cosine squared of x is just 1. Negative 1 times 1 is just 1. So what I get is that my derivative is 1 over sine squared of x. Sorry, negative 1 over sine squared of x. 1 over sine of x is cosecant of x. So negative 1 over sine squared of x would be negative cosecant squared of x, which I put a check mark because that's exactly what we wanted it to be. All right, moving on. Last one, number 3. Number 3 says that sine times cosine times cotangent is just the same as cosine squared. The derivative of cosine squared is negative 2 cosine of x sine of x. Kind of just asking you to take my word for it. Have we done that yet? I guess we've kind of done that already, right? We saw up here in number 1 that the derivative of cosine squared is, there's 2 of these negative sine of x, cosine of x things. So we've actually already seen that the derivative of cosine squared of x is negative 2 sine of x, cosine of x. But anyways, I give you that in number 3. I say that's true. So I'm saying that the derivative of cosine squared of x is this thing. And then I'm saying cosine squared of x is the same as this thing. So the derivative of this thing right here better be this. Let's see. I want the derivative of sine of x times cosine of x times cotangent of x. Kind of looks like a product rule question, but it's not. Well, it is, kind of. It's the product of 3 things. We don't really have a rule for the product of 3 things. We just have rules for the product of 2 things. Fortunately, we can think about this as just the product of 2 things. We can think about it as the product of sine of x times cosine of x and cotangent of x. What I'm saying is associativity says that if you're multiplying 3 things together, multiply the first 2 together and then multiply that by the third. So the derivative of this product is just the derivative of this product times this. But when it's written like this, you can kind of see the product rule. It's sine of x times cosine of x times cotangent of x. So my f is sine of x times cosine of x, and my g is cotangent of x. What I'm trying to say is this derivative is just the derivative of the first thing, sine of x times cosine of x, times the second thing, cotangent of x. And then to that I want to add the derivative of the second thing, the derivative of cotangent of x, to the first thing. I guess I don't need parentheses there, sine of x times cosine of x. So I've used the product rule, and now I just have to figure out all these derivatives. However, when you're figuring out all these derivatives, figuring out this first one here, you have to use the product rule again. The derivative of sine times cosine is the derivative of sine times cosine plus the derivative of cosine times sine. So this derivative here is this whole mess. I want this derivative to get multiplied by cotangent of x. So I want this whole mess here to get multiplied by cotangent of x. That's this part. And to that I want to add the, I want to add the derivative of cotangent of x. However, I know the derivative of cotangent of x is negative cosecant squared of x. So I want to add negative cosecant squared of x. That's this part. But then I'm not done because I have to multiply that by sine of x, cosine of x. I'm almost done with the calculus. Derivative of sine is cosine. So I have cosine times cosine. I have cosine squared plus the derivative of cosine is negative sine. So I got negative sine times sine. I got minus sine squared of x. So I get this thing times cotangent of x minus cosecant sine cosine. Sorry, cosecant squared sine cosine. Can I squeeze all that in? Nope. Cosecant squared of x times sine of x times cosine of x. So I get this mess right here is my answer. That's the good news. The bad news is my answer is supposed to be -2 sine of x cosine of x. Hopefully this whole mess will simplify to this. The easiest way to simplify trig functions is to change everything into sines and cosines. So cotangent, as we saw earlier, is cosine over sine. So this is cosine squared of x minus sine squared of x times cotangent is cosine over sine, cosine of x over sine of x. And then from that I want to subtract cosecant is 1 over sine, so cosecant squared is 1 over sine squared. I'm going to want to multiply that by sine, it's a times there, and then multiply that by cosine. So I get this mess here, still not where I want to be, but hopefully this is equal to what I want it to be equal to. Okay, cosine squared minus sine squared. Actually, no, let's do this a different way. I'm going to want to put these two things together. I'm going to need a common denominator if I'm going to put them together. So what I'm going to, well, alright, I'm going to show this in an extra step. I'm going to take this cosine of x divided by sine of x and distribute it into these parentheses. What that gives me is cosine cubed of x over sine of x minus cosine of x times sine squared of x over sine of x minus sine of x times cosine of x over sine squared of x. So I get this mess. I wish I had a common denominator. I don't have a common denominator, but I can multiply this by sine over sine and this by sine over sine to make them all over sine squared. Actually, there's an easier way to do it. I cancel out this sine and this sine. Right? I cancel out this sine and one of these sines, and then I will have sine of x as my common denominator. What I'm saying is leave this cosine cubed alone. Leave this cosine sine squared alone. But over here, cancel out this sign with one of these signs, so you're left with just cosine of x. And that gets us here. Still not where we want to be, but maybe it's close. Well, the easiest way to finish this up is note that all three of these terms up top have a cosine in them. So I can factor out that cosine, and what I'm left with is cosine squared minus sine squared minus 1 over sine of x. And maybe you think that doesn't help. However, we have this Pythagorean identity that says that cosine squared minus 1. Let's see. Now let's do it the other way. Well, what I'm trying to say is we know that sine squared plus cosine squared equals 1. So if I subtract 1 from both sides here, this is equivalent to saying that, well, which form do I want to use? Let's get rid of the cosine. So I could say that cosine squared minus 1, I subtracted 1 from both sides of the equation, is equal to negative sine squared if I subtract sine squared from both sides of the equation. So why that helps me is I have cosine squared minus 1 over here. So if you leave this cosine of x on the outside, cosine, let me rewrite this, cosine squared of x minus 1, I have this thing, and then from that I want to subtract sine squared of x. So really what you could do is, I mean, parentheses don't change anything here, but you could put parentheses in here if you really want to see the cosine squared minus 1. Because cosine squared minus 1 is negative sine squared of x. So this is cosine of x times negative sine squared of x minus sine squared of x divided by sine of x. And I think we're done. I know it doesn't look like it, but negative sine squared of x minus another sine squared of x is negative 2 sine squared of x. And then we have to multiply that by this cosine of x, and then divide that by sine of x. But what we can now do is cancel out this sine and this sine, and get negative 2 sine of x cosine of x, which better be the same answer because I'm out of room, but it is, negative 2 sine of x cosine of x. So part 3, if you do all the trig substitutions, and there's lots of different ways to get it, you can get down here and you get the right answer, but that's finally the end of this perfect problem.